half a mile long, 31 million bricks, 14,000 tons of steel, 70,000 tons of cement. Tower Bridge. When a structure of this magnitude needs repair, there is only one engineering company you can truly rely on. Only one company that has the strength, reputation and skills to tackle such a job. LES Engineering. LES Engineering has over 20 years of experience on projects large and small, working for clients that include many blue-chip multinationals. LES Engineering delivers engineering projects from inception through design and planning to completion. LES Engineering specialises in all aspects of mechanical engineering, from original design to installation. The LES team of highly skilled designers can design anything for any job, and the skilled craftsman can fit it. Tower Bridge is no exception. Tower Bridge opened to worldwide acclaim on the 30th of June 1894 at a cost of over £1 million, which is a whopping 55 million in today's terms. The bridge's original design came from Sir Horace Jones, the City of London architect of the day. It was built in the highly fashionable style of the time, now known as Victorian Gothic, an architectural style that mimicked the Gothic churches and castles of Eastern Europe in the Middle Ages. It is this design that gives the bridge its imposing, solemn presence and marks it out as one of England's finest monuments, and is a testament to the engineering talent of the Victorians. The bridge itself is constructed of a steel frame with a stone covering. This is covered in concrete and granite. The decorative outer aspect of the bridge is comprised of Welsh stone cladding. The bridge is then decorated with wrought iron and carved gargoyles, again reflecting the bridge's grand stature. The bascule design of the bridge, bascule coming from the French for seesaw, was chosen over many other potential designs because of its benefits as a simplistic and functional approach to allowing the passing of shipping. The bridge's lifting mechanism was originally powered by steam, but in more recent years has been replaced by hydraulics, which has, like all mechanical devices, worn out. Its parts now need replacing, upgrading and repairing. Today, the bridge weighs in excess of 125,000 tonnes, and it is still opened over 500 times per year. It's one of London's most important monuments and tourist attractions. Greg Stratford is the manager of the Tower Bridge project.
We found out about the project. What it was an initial contact from a consulting engineer in London. We'd worked with them previously on a project, and they came to us and said, would we be interested in tendering for Tower Bridge, the refurbishment work of the bascules. Obviously my MD said yes, and we went through a level of pre-qualification, and we finally received the tender information, and the contract went from there. We put a proposal forward, which was eventually accepted. You can talk to most people and they'll recognise it as being a landmark, and for us to be able to say yes, we will be doing the refurbishment on Tower Bridge is an achievement and a half. It's something we're very proud of. My understanding of the scope, as we see it at this minute in time, is basically three areas of work. There is what is described as the nose bolts, the resting blocks and the pawls. The nose bolts, they're the device that lock the bridge in position when it's in a closed position. The resting block is the device the bridge comes down and sits on when it's in the closed position. And the pawl is the device that locks the back end of the bridge in position so it's safe for traffic to drive over. And the reason for all these three main areas of work to be carried out is to resolve a problem on the main bearings. The bearings are presently witnessing the loads being driven across the bridge, and all the load is being transmitted directly through the bearings. What we're hoping to achieve when we finish this is to take the load off the main shafts so that the load is transferred through to the structure as was probably originally intended by the engineers back in the 1800s. The nose bolts, what they basically are is it's a 6-inch square, 150mm square, approximately 6-foot long shaft made out of a material called the N24. Very high quality steel, and basically that's driven into position between the south bascule and the north bascule to engage the two decks together. There's 4 in number. They're machined to quite tight tolerances, and they're held in a material called ferroform, which is a specialist material that we've designed into this particular contract. And when the bridge comes together, they're driven in hydraulically, and they locate the bridge together to prevent the bridge from bouncing as traffic drives across from the south bascule to the north and from the north to the south. On the resting block, the design that is being put forward contains a load cell. The load cell will enable the control systems to determine the load that is being applied by the bridge on the resting blocks in the closed position. The pawl will actually physically lift the back end of the bridge by approximately 50mm. That 50mm will allow about 5mm of clearance in the bearing and stop the vibrations being transmitted through the bearings to the bridge.
Planning is vitally important for budget, deadline and safety.
You make it a lot of small jobs. You break it down across all the different areas of work and then treat each individual item as a specific task. And then each of them specific tasks are brought together to give you the overall plan. There's a small design team of 4 people working on the design. Obviously I'm very active in the day-to-day runnings of the project, and then as we progress through the manufacture there will probably 8 to 10 people in the machine shops involved in the manufacture of the components, and again the fabrication of the components will probably call on sort of 7 to 8 people in the fabrication shops. The initial programme, when we get down to London, our initial look at the sort of numbers are in the sort of regions of about 45 to 50 people on the day shift and probably 25 people to 30 people on the night shift. We started work on the project back in the beginning of 2000, and that has come through to the order being placed as we speak now in January 2001, and the programme from there is we're going through a design window and we will design certain component parts as that design window progresses, and then the completion of all component parts by November 2001, ready for shipping down to London, so we are ready for an installation window of January 2002. Safety, very, very important feature of the project. It's being managed under CDM. We have a lot of things to do and prepare our method statements for submission to the client, risk assessments, because certain areas of the work there is some quite high risk, working over water, accessing what is a Victorian structure. In today's standards there's certain things that wouldn't be allowable, and we've got to take them into consideration. One of the things we've obviously done is certain areas of access you need fall arresters, so that all of the people working in them areas will be trained in the use of safety harnesses, fall arrest equipment, and also will be wearing life jackets. Again, it's a belt and braces approach, but that's what the method statements and risk assessments have given us. Tower Bridge, an historic monument. It is a Grade 1 listed structure. Yes, it's going to present some challenges because at the end of the day we can't make no major changes to the structure. So what we are working with, we're working with some information, some very dated drawings of some of the component parts that are present, and we'll have to take very careful consideration of what is there to ensure that what we put in will fit. So we've had to be very careful in looking at that side of the bid process. A lot of the work will take place in areas which are never seen by the public within the structure of the bridge itself, within the bridge decks, from the nose bolts, and where the resting blocks are. Although they're visible to the public when they go past it on the pleasure craft, you don't really see what's going to be there. So we've got the opportunity to put new equipment in, modern equipment, equipment that will take the bridge into the 21st century. Tower Bridge for me is obviously going to be a challenging project. I'm very pleased that LES as a business has won the order, having put a lot of work in with myself and colleagues in preparing the tender documents. We had some very late nights in getting the information together because it's quite complex, but now we've got to that point where we've been awarded the order. It's going to be a very interesting challenge, and I appreciate there'll be one or two late nights along the way, 1 or 2 days down in London. For me personally, it's a challenge. It's something I'm very proud of to be associated with, and I'm proud for LES to have won it.